Hello everybody, how are you? Today we are going to learn about transformer tests. There are different types of transformer tests: open circuit test, short circuit test, polarity test, and load tests. From these, the two main types of tests are open circuit test and short circuit tests. These two tests on a transformer helps to determine the parameters of the equivalent circuit, the voltage regulation, and the efficiency. These parameters of equivalent circuit is used to determine the resistance R1, primary reactance X1, secondary resistance R2, secondary reactance X2, and magnetizing reactance and core resistance. And the voltage regulation and efficiency of a transformer can be measured by using these transformer tests. And a complete analysis of transformer can be carried out once its equivalent circuit parameters are known. The power required during these two tests is equal to appropriate power loss occurring on a transformer. Now we are going to deal with open circuit test. In this test, voltmeter, wattmeter, and ammeter are connected to a low voltage side of a transformer, and high voltage side is left open. Here, as we look here is a variac or the auto transformer which have 230 volt 50 Hz single phase supply, and this is the ammeter which is connected in series because current is in series is equal, while here is a wattmeter used to measure the power loss which is core loss, and here is a voltmeter which is connected in parallel which is voltage in parallel is equal, and here is a voltage transformation ratio, and here is a step up transformer, and here is the low voltage side, and here is the high voltage side. So all the measuring instruments ammeter, wattmeter, and voltmeter are connected in the low voltage side, and the high voltage side is left open. So the voltage applied to the primary, that is low voltage side, is varied with the help of variable or ratio auto transformer. Here is the auto transformer used to vary the voltage applied in the primary winding, and the wattmeter when the wattmeter reading is equal to rated voltage of low voltage winding. All the three instruments are recorded, which means this variac is varying with a desired voltage. When the desired voltage level reaches, the ammeter records the no load current, the wattmeter records the core loss, and the voltmeter records the voltage, while high voltage side remains open circuited, and the ammeter records no load current or exciting current IE, and the input power is given by the wattmeter reading, which consists of core loss and ohmic loss. This ohmic loss is I square R, and here core loss is equal to the primary applied voltage times no load current or exciting current cosine of theta naught. Now the load power factor, no load power factor is cos omega cos theta, which is equals to core loss over V1 over IE here, where V1 is the applied voltage and IE is exciting current, which is no load current, while PC is the core loss current. Now IC, the core loss current, is equals to IE exciting current times cos theta, while the magnetizing current IM is equals to IE sin theta. Here IC is equals to PC over V1 at the core loss resistance RCL, which is equal to V1 over IC, and IC means IE cos theta naught, while V1, when we multiply this by V1 over V1, which implies that V1 square over PC, since this value is a PC, and core loss resistance equals to PC over IC square. which gives PC over IC means here this value substitute, then the magnetizing reactance XML is equals to V1 over IM, which is substitute this value in place of IM, which gives this result. And generally, open circuit test gives the following main information, which is used to measure the core loss at rated voltage and frequency, the shunt branch parameters, which is RC, core loss resistance, and magnetizing reactance, while a transfer ratio of a transformer. And the next type of transformer test is short circuit test. In this case, the low voltage side of a transformer is short circuit here. Here is the low voltage side of a transformer which is short circuited and all the elements are placed or connected at the high voltage side. Here in this case, the high voltage side is in this side. Here is the auto transformer used to vary the current, and here is the ammeter which is connected the wattmeter, and here is the voltmeter. And in short circuit test we adjust the auto transformer to its rated current, while in open circuit test we adjust the voltage with its rated voltage. And here is a simplified diagram of short circuit when secondary or low voltage side is short circuited. Here is the center resistance or primary resistance in transformer. Here is the primary reactance. Here is the shunt parameter, which is core loss resistance and magnetizing reactance, while here is the secondary reactance, and R2 is the secondary resistance, and the applied voltage adjusted by auto transformer to circulate a rated current in high voltage side. Wattmeter in short circuit test records the core loss and ohmic loss in both windings. And the equivalent linkage impedance referred to high voltage side is equals to Z with respect to high voltage side is equals to short circuit voltage over short circuit current, while the equivalent resistance referred to high voltage side RH is equals to short circuit power or short circuit current square, and equivalent linkage reactance referred to high voltage side is equals to impedance square minus resistance square. Generally, the short circuit test gives the following informations, which is used to determine the ohmic loss or copper loss in induction motor at rated voltage, rated current and frequency, while the equivalent resistance and equivalent linkage reactance. Voltage equation of a transformer can be determined from the data obtained from short circuit test. Now, the data of open circuit and short circuit test is necessary for obtaining all the parameters of equivalent circuit, which is used to determine R1, X1, R2, X2, RC, and XM, while for calculating the transformer efficiency also, and for calculating core loss and ohmic loss. Now we can do this example. Here is 20 kVA 2500 per 250 volt 50 Hz single phase transformer gives the following test results. For circuit test or for low voltage side, it is 250 volt 1.4 and 105. And for short circuit test, here is the data. Then the parameters of approximate equivalent circuit referred to high voltage side and low voltage side. And also draw the exact equivalent circuit referred to low voltage side. Now, first we determine the open circuit test in this case, and first of all we determine the cos theta or the power factor. Normal power factor cos theta is equals to PC over V1 IE, where PC is the core power loss. Here is recorded in 105 watt over V1 times IE, which is 250 times 1.4. Cos theta is equals to 0.3, while theta is equals to cos inverse of 0.3, which is equals to 72.55, and sin theta is 0.954. If we determine the cos theta or the power factor, we can calculate the core current and magnifying current. The core current is determined based on the data given above, and ID, which is equals 1.4 multiplied by 0.6 is this value, and the second one is IA, magnetizing reactance, which gives 1.336 amp. Then now we can calculate core loss resistance and magnetizing reactance. The core loss resistance is determined by V1 over IC, which means 250 by IC. IC means 0.42, while magnetizing reactance is determined by V1 by this IM, which is equals to 187 ohm. While from short circuit test, VDEH, which is the impedance at high voltage side, is equals to short circuit voltage over short circuit current, which is the short circuit voltage is 104 here, and the short circuit current is 8. The 104 over 8 gives short circuit impedance, or the impedance at high voltage side here, which is 13. REH, the resistance at high voltage side, gives short circuit power 30 over 8 square, which is equals to 5, and now the reactance at high voltage side is 12. Then the equivalent circuit referred to high voltage side is the core loss resistance remains the same, since the equivalent circuit parameter at low voltage side, and low voltage side would be changed, it remains the same. While we translate this value into high voltage side value into low voltage side value, the resistance at low voltage side value is equals to the resistance at high voltage side times 1 over k square, where k is the voltage transformer ratio, which is calculated here. Transformation ratio k is equals to 2500 over 250, which gives 10, and here k is 10, so 5 over 10 gives this value, and the reactance at low voltage side is equals to reactance at high voltage side multiplied by inverse of this voltage transformation ratio, which gives this value. And here is the approximate equivalent circuit referred to the high voltage side, which is XEL, which value is this value, and REL, which is this value. And the core loss or the shunt parameters remain the same, because it is calculated at low voltage side of the transformer. Now, when we draw the exact equivalent circuit, simply we divide this value 0.12 and 0.05 into 2 value, and this is in part 0.06 and this part 0.06, while in this part 0.025 and in this part 0.025 is divided both sides in equal parts, and we can get the exact equivalent circuit of a transformer referred to low voltage side. Now we are going to do with equivalent circuit parameters referred to high voltage side. So in the last, here is a low voltage side and here are high voltage side. Now we translate these low voltage side shunt parameters at low voltage side into high voltage side. So RCH, which is core resistance at high voltage side, is equals to core loss resistance at low voltage side times k square voltage transmission square. And here magnetizing reactance at high voltage side is equals to magnetizing reactance at low voltage side multiplied by k square, which is equals to this value. Now the resistance and reactance at high voltage side, which is calculated above here, remains the same. Now we are going to do by remain the same this value, and by substituting in place of this value to this value, and we can draw here exact equivalent circuit parameter referred to at low voltage side is determined by dividing both sides, as I have told you later here. To draw exact equivalent circuit, we can divide this value 0.12 into 2, which is 0.06 and 0.06 at both sides, which is 0.06 and 0.06 into 2. And now we can divide 0.05 into 2 by 0.025 and 0.025 at both sides. But this value remains the same, and this is the exact equivalent circuit referred to low voltage side. Now we are going to do with the exact equivalent circuit referred to high voltage side. Simply we substitute this value, shunt value, to this value 559,500 and 18,700 is substituted into this value and this value respectively, while the other value remains the same. Thank you for watching our videos. Please share and subscribe to others.